Hello, and welcome to pfSense Bootcamp, a series of videos aimed at those seeking proficiency in installing, deploying, and configuring pfSense. In this video, I'm first going to cover an erratum from the previous video. Then we're going to cover the DHCP process, including DHCP at the console and within the GUI, and also DHCP version 6 at the console and within the GUI. And we're also going to cover DHCP Relay and DHCP version 6 Relay. And that's a lot to cover in one video, but I think we can do it. So, first, an erratum from the previous video. In the previous video, I was having trouble accessing the pfSense web GUI from Firefox using an IPv6 address. And what I discovered was the problem was that you have to enclose an IPv6 address in square brackets. So right now I typed in open square brackets and HTTP s colons open square brackets and FD 12:3456:789A:1, and note that I changed the IP address of the pfSense box. For it was FD 123456789:1:1, and I just changed to ::1 to simplify the addressing. And so as you can see now, we can access the pfSense web GUI from using IPv6 addresses. So that took 2 minutes to find out how to do that with a simple web search. So then we'll go back to DHCP, and we're first going to cover the DHCP process. And you may wonder why we don't just do static IP address allocation. So in other words, if we had the subnet 192.168.1 and we wanted to assign IP addresses to nodes, we could just do it statically from each of the nodes. We could do, assign, say, 192.168.1.10 to the first node, and then 192.168.1.11 to the second node, and so on. We'll assume that we'll reserve the first few addresses for routers and such. But the problem with that is that the more nodes that you have on a network, the harder it is to do static or manual configuration and not have two or more machines end up being assigned the same IP address. It's hard to do it sometimes when you only have a few machines on your network, but when you have many nodes on your network, it's that much more difficult. And what happens when two or more machines are assigned the same IP address? Well, that behavior is undefined, so we don't know what will happen. One would think that the node that was first assigned the duplicate IP address would be able to access the network, and the other ones would not. But it's possible that all nodes with the same IP address will be able to access the network intermittently. It could be that the last node to be assigned the IP address will be able to access the network. We just don't know. We know that it's going to be bad news for us as network administrators if it doesn't work. So this is why dynamic host configuration protocol was developed, because it was realized that if you have a server that hands out IP addresses to nodes on the network, it would make life a lot easier. And the bonus to all this is that if you have a server handing out IP addresses, you can also have them hand out other configuration information relevant to the network. So with this in mind, DHCP was developed. It was originally defined by RFC, Request for Comments 1531, and then it was immediately realized that there were deficiencies in this original definition, and it was amended in 1541. Both of these RFCs were issued in October of 1993, and DHCP was updated in RFC 2131. And DHCP covers three kinds of allocations. There's dynamic allocation, whereby IP addresses are new IP addresses are handed out to nodes. There's automatic allocation, which covers the scenario whereby a node that had previously been assigned an IP address may like leave the network and then return to the network, and the DHCP server recognizes the MAC address and says, well, this node already has an IP address whose lease didn't expire, so the server just gives back the IP address that had previously been allocated, rather than allocating it a new IP address. And then the third type of allocation is static allocation, whereby some nodes we want these nodes to have the same IP address all the time. For example, a resource, say a printer, an FTP server or web server. We don't want these resources to have be assigned different IP addresses, so that we don't, we would have trouble locating them. So we have the DHCP server allocate these addresses statically, and it seems somewhat counterintuitive initially, or that the DHCP server would be in charge of this, because we're talking about dynamic host configuration protocol after all, not static host configuration. But it it kind of makes sense when you consider that, as long as you have a centralized server that's handing out IP addresses, you might as well have it handle also the static address allocation. So moving on, let's talk about the DHCP handshake. There are 4 steps in this handshake, and when a node initially comes on the network and doesn't have an IP address, we have kind of a chicken and egg type of a situation where the node needs an IP address to communicate with the network. But how does it communicate that it needs an IP address in the first place when it doesn't have an IP address? Well, the answer to that is it sends a broadcast message. So this is DHCP discover message, whereby the node just queries the network to see if asks if there's any DHCP servers on the network. Then the second step is DHCP Offer. This is a step in which one or more DHCP servers provide an IP address being offered, a subnet mask, a lease duration, and a DHCP IP address. So, as I said, more than one DHCP server can complete this step. And in the next step, we have DHCP. So the DHCP offer is done by the DHCP server. DHCP request is done by the node requesting an address again, and it's also a broadcast message, but only one DHCP offer of the one or more offers that were made will be accepted. And then in the last step, we have DHCP ACK. This is done by the DHCP server. And in this step, the DHCP server provides lease duration and configuration information. You note that the IP address had already been provided in the DHCP offer step. So that's the DHCP handshake. And now we'll go straight into configuring DHCP. So as you recall, we had our virtual network here. This is our Linux Mint box, and just so you can see, we currently have it set up with IPv6 addressing, and we have IPv4 disabled. IPv6 is set up as manual, so we did not utilize DHCP yet. So we want to change this so that we enable DHCP6, or rather DHCP. We're going to do DHCP first. So one of the things that we want to get to the console, and I keep on talking about configuration of the console, but actually the console can be accessed remotely, and the way that we do this, just to show you, we go into Advanced, in the System Advanced in the Web GUI, and we make sure that Enable Secure Shell is checked. And we also could do disable password login for secure shell. I may make a video later on showing how to do this. But in the first case, initially we can just check enable secure shell. We can also change the SSH port here. This is a good practice, in my opinion, because a lot of times you can defeat a lot of hackers just by changing the port from whatever the default port is. Kind of security through obscurity. But right now we can leave it as the default SSH port of 22. And we'll go to the terminal here, and we'll just access the console by doing SSH. Actually, I think we can just bring it back from our previous history. And we have admin because we want to access the console as the admin, and and we give this is the IP address of the pfSense box. So we'll just do that, and it's prompting us for the password. So I'll type in the password, and we're in. So the first thing we want to do is I want to first set up just DHCP, for IPv4, or legacy DHCP, as it were. So I'll type in 2 on the menu here, and it says available interfaces, WAN, LAN, DMZ. We want 2 for LAN. It'll ask us for the new LAN IPv4 address. I don't want to change this, so I'll just type in the old LAN IPv4 address. And the subnet bit count will not change, so it's 24. And there's it says for LAN, press enter, or for none. So it's the LAN IPv4 upstream gateway address. So there we go. And it says enter the new LAN IPv6 address. Again, I don't want to change this, so I'll type in FD12:3456:789A ::1. And the subnet bit count will stay the same. It was 48. Press enter. Do you want to enable the DHCP server on LAN? Yes, we do. Enter the start address of the IPv4 client address range. And it's going to be 192.168.0.100. As enter the end address. I'm going to give it 100 addresses, which should be more than enough. 192.168.0.200. Do you want to enable the Dhcp 6 server on LAN? I'm going to type in no. Do you want to revert to HTTP as the web configurated protocol? No. And now it's reloading. So it has made the changes that were needed, and now the DHCP server is running, but we still need to do the configuration on the client side. So here we're going to go into networking. I'm going to go into options. I'm going to disable IPv6 for the moment. I'm going to go into IPv4 settings, and we're going to do automatic DHCP as our option. So we don't have to enter any of the information about the addresses or DNS servers, because it's going to get those from pfSense. So I'm going to click on Save Now, and we're going to click this on and off, and it should give us an address. And it looks like it worked, because it gave us an IP address, and it has default root and DNS server. So let's see if it actually worked. Well, we can actually do this. We can open up another terminal and try to ping the pfSense box. So we'll do ping 192.168.0.1, and it seems to work. So let's see if we can get into the web GUI using that address now. Let's do 192.168.0.1, and it's asking us for login credentials, so we'll type those. And we're in. And so now we want to show DHCP configuration in the web GUI, and we'll go to Services, DHCP Server, and you can see Enable DHCP Server on LAN Interface is already checked. We also see our range is what we defined at the console, so 100 to 200. But you also see that we can do a whole bunch of things that we couldn't do at the console. For example, additional pools. We can add additional pools of addresses. We can define additional WIN servers and DNS servers. It's unlikely that you actually use a WIN server, but if you do, you can enter it here. And then you can specify an alternate gateway, domain name, default lease time, maximum lease time. Again, it's unlikely that you'd have to change these, but they're available to change. And then we scroll down to the bottom, and then we see something that actually is pretty important: Dtp Static Mappings for this interface. And again, this is another thing that you can't do from the console. So let's say that let's click on Add so that we can show how this is done. So we have a MAC address. I don't have a real MAC address, so I'm just going to do 11223344. 5566. This wouldn't work in real life because I don't think this is 112223 is not a valid manufacturer ID for any network card. Then we do IP address. We could do 192.168.0. Say 25. And it says if an IPv4 address is entered, the address must be outside the pool. So obviously we don't want to assign an IP address that is within the range, the DHCP range. Otherwise, we'll run into the problem with duplicate addresses that we talked about earlier. In fact, let's see what happens if you try to do that. So we'll do 150, which is right in the middle of the range that we specified, and then we'll do printer for the host name. We'll do this description, the office printer, and do save. And so it did flag that error. So it said the IP address must not be within the DHCP range for this interface. So if you try to do that, that answers my question. It does error checking on that, so that's good. So we know the DHCP routines are pretty robust. So then this time it worked, and we had to click apply changes to apply the changes, and now we have a static mapping for the printer. So that covers the DHCP configuration. Now we're going to do DHCP version 6, and DHCP version 6 is a little bit different, and for a variety of reasons, but the main reason is this. I'll show you. It's actually DHCP server and RA for router advertisements. So you have to DHCP V6 in and of itself does not provide a way of knowing what the gateway is for your network. So you have to also configure router advertisements in order to get DHCP V6 to work. So, and there's some other differences, but that's the main one. So we will now configure DHCP V6. And we'll go back to the console here. Show configuration in the console first. And again, we're going to select 2. If it lets me type it. No, it's not letting me type for some reason. May have to open another terminal. Yeah, I'm going to open up another terminal, I think. Okay, let's try that. Okay. SSH at FD1234567898.1. No, it says network is unreachable. Oh wait. Oh, my bad. See, I forgot that we switched to IPv4. Okay, well. So yes. Password. Type in the password here. So we'll get rid. So now we're again logged into. Oops. We're again logged into the console here, and we'll type 2 for set interface's IP address. We'll select 2 for LAN, and I don't want to change the IPv4 address, so I'll keep that as 192.168.0.1. The subnet bit count is 24. We'll press enter here. We want the new LAN IPv6 address. So, and we're going to keep this the same too. So, here we go. And subnet bit count is 48. Press enter. This time we'll say we will not enable the DHCP server on LAN. We're just going to enable the Dhcp V6 server. So, do no. And we will enable the Dhcp 6 server. And we'll enter the start address of the IPv6 client range. So we'll do, how about FD 123456789A : 10. And the end address will be FD 123456789A 99. That should leave plenty of addresses. We're not really doing a good job of exploiting the increased address space of IPv6 addresses, but whatever. And we'll type in no here, and reloading. And I just remembered something here, which is that we need to do router advertisements too. So we actually cannot complete the Dhcp V6 setup from within the console. So we had to go back here and go to router advertisements, and we had to set the router mode to managed. And what you're getting out of this is client address is only assigned by DHCP 6. So there's different options here. You can select router mode, which is router only. Clients having set their IPv6 addresses statically. Unmanaged is get addresses through stateless address auto configuration, and assisted is a hybrid mode. Which assigns client addresses by either DHCP version 6 or both. So I'm going to set it to managed, and then I'm going to scroll down and click on save. So this should reload, and let's go to the Dhcp V6 server tab here. And as you can see, Dhcp V6 is now enabled because we enabled it in the console and the range that we had set up. And we still need to do the client-side configuration once again. So we're going to go in and do that. So we'll do options, and we'll do IPv4 is now an automatic. We'll disable that. IPv6 we will set to automatic, and we'll click on save, and we'll toggle the connection on and off again, and we should get, oh, we got an IP address. So let's see if we can ping. This is the moment of truth. Okay, let's. This terminal is dead, so I'm going to close it out. We can open another terminal. Close terminal. I'm going to try to ping the pfSense box again using IPv6. And it worked. So now we should be able to access the pfSense web GUI from using the IPv6 address. So let's do that. Yes. Okay, here we go. And it worked. So we now have IPv6 enabled, but not IPv4. And we can go back if we want. And so we have, okay, wait, I went to real, okay, I didn't want to do that. DHCP server and RA. Okay, so we have DHCP version 6 set up, as you can see, and we'll go back into services. So I just wanted to briefly show DHCP Relay. So go into here, and here we can click here for enable DHCP Relay on interface. And what DHCP Relay is, quite simply, is we may not want to set up pfSense as a DHCP server, but we may want to just relay DHCP requests to another server, which is the DHCP server. So what we do simply is we click on DHCP, enable DHCP Relay on interface. We select the interface or interfaces where we want the request to be relayed through, and we also we have append circuit ID and agent ID to which will append the pfSense interface number and agent ID to the DHCP request. And then here, which is the important part, we specify the IP address of the DHCP server. And note that we can have more than one server here. So we can type in, for example, 192.168.2.1, and then do add, and then we type in another one here. So that's very simple. And please note also, you can have the DHCP server or the DHCP relay configured for, but not both. And the same goes for DHCP V6. You can have DHCP V6 server enabled or the DHCP V6 relay, but not both. So take that into consideration. And just one last thing, we can configure, now we disabled the DHCP server for DHCP for IPv4, but we can enable it now. So I'll just check the enable box, and now we can scroll down to the bottom of the page here and do save. So now we have both the DHCP and DHCP V6 servers running, and so now we should be able to go back and go into IPv4 and set this to automatic DHCP and save, and toggle it on and off again. And now it's giving us an IPv4 address, because IPv4 apparently takes precedence over IPv6. So there, in this video, we showed how to configure both DHCP and DHCP V6, and we also showed DHCP Relay service in pfSense. Hope that this video was helpful in showing how to do that. In the next video, I will demonstrate how to configure the captive portal service, and not sure how long that will take. It'll probably be about the same length as this video. So if you like this video, click on, give it a thumbs up. If not, give it a thumbs down. And remember, if you like these videos, consider subscribing to my YouTube channel, and also consider sharing these videos via your social networking sites. So that's it for now. I'll see you in the next video.